Alright, in this video we have another short video about topic. We have topic 8 here, which is about finding inverse functions. Remember, the main thing about an inverse function is that the input and the output have been switched. So as long as I switch the input and the output, technically I've got my inverse, but I have to make sure that my output has been solved for. That's the most proper way to write an inverse function. So in my first problem, the inverse of f of x is x cubed minus 2. I'm going to take my input and my output. Here's my output, f of x, and my input x, and I'm going to switch them. So I'm going to write my x on the outside of the equation, and then I'm going to put my f of x on the inside of the equation, and everything else about the problem is going to stay exactly the same. So I still have my value on the right side of the equation being cubed and having 2 subtracted. That's still happening over here, but I've switched my input and output. Now the proper way for our notation to happen when we found an inverse, because this is now the inverse, the proper notation for this is going to be to put a little -1 as a kind of an exponent on my output value. So instead of f of x, this is technically called f inverse of x, so f -1 of x. Now if it's easier for you to substitute the letter y here and switch your x and y, that's totally fine, but the final answer will have f inverse written in it, so I want to make sure you're familiar with that. Alright, so we switched our input and output, which means technically we have our inverse, but it's always proper to solve for the output. So we're going to try and get f inverse of x by itself. Now, my f inverse of x is being cubed and having 2 subtracted from it, so I'm going to undo those in the opposite order. To get f inverse alone, we're going to add 2 to both sides. So we get x plus 2 is the inverse cubed, and then we just have to undo the cube by cube rooting both sides. So cube root here and cube root there. So that'll leave f inverse by itself. The output is alone, and we have the cube root of x plus 2 all by itself on the left. So this is our inverse function. It's important to do those in the proper order. If it's helpful for you to make a list of what's happening to your inverse, first it's being cubed, then we're subtracting 2, so that you can undo them in the opposite order, 2, then 1. It's important that we add 2 first, then cube root. So it's helpful to make a list sometimes to know how to undo steps in the opposite order, but as long as you're switching your input and output first and then solving for your output, you should be fine. So let's go ahead and try that for question 22. Our function dt is 16t squared. It represents the distance in feet that a coin is dropped into the well in t seconds. So we want to go ahead and find an inverse for this function in terms of t. So here's our function dt. Whoa, goodness. I don't know what that was. Let's try that again. d of t is 16t squared. My input is t, my output is dt. So the first thing I have to do is swap those. So I'm going to put my t on the outside, and I'm going to go ahead and put my dt on the inside, d of t, and my d of t has to be squared. Now again, this is my inverse, so I can put my little -1 here to show that this is the inverse now that I've swapped my input and output. And all I have to do is get d of t by itself to be done. So if we want to take a look at what's happening to d of t in order, the first thing order of operations says happens is that exponent. Then we multiply by 16. So to undo these steps in the opposite order, we'll have to divide by 16 and then square root. So to get t alone, let's divide both sides by 16. So we get t over 16 is d inverse of t squared. And now we want to square root both sides. So we'll square root here and square root here. Now, we just inserted a square root into this equation. The cube root is fine. We're allowed to get just one answer for a cube root. A cube root has only one solution. But every time I do an even root, like a square root or a fourth root, I always have 2 possible answers. So we always want to put a plus or a minus every time we insert a square root to something. So plus or minus the square root of t over 16. So the d inverse is by itself now, and we have the plus or minus square root of t over 16. Now this can't be our final answer for one very simple reason, and that's that the square root includes a denominator and we're not allowed to have a radical in the denominator. So the easiest way to simplify this problem is going to be to break up the square root. If I'm taking the square root of a fraction, I'm allowed to take the square root of the top and the bottom separately. So what we have here is the plus or minus square root of t over the square root of 16. And now we can see that the bottom can be simplified really nicely. This is the plus or minus square root of t over the square root of 16, which is just the number 4. So plus or minus square root of t over 4. And that would be our final answer right there. All right, we're going to pick up with topic 9 in the next video.